So now we're going to get into actually finding absolute extrema, finding the absolute max and the absolute min. And to do this, we use a test called the candidates test for absolute extrema. What this says is, the first thing we have to do is we have to find our critical values of our function. I'm asking you to find the absolute max or min of a function on some closed interval. We'll find the critical values of our function that happen to lie in that interval. Then, I'm just going to make a table of values for my original function. And for the x's, I need to include all possible candidates, hence the title, for the absolute extrema. And absolute extrema, as I think I've already mentioned, can occur at those critical values or could occur at the endpoints. So I'll make that table of values, and then I'll look at my y values. The highest y value is the absolute maximum value. The lowest y value is the absolute minimum y value. Take a moment and please copy that down, and then copy down that first problem as well, and we'll work through that one together. So I want to find the absolute extrema of this function on that closed interval. The first thing we need to do is find our critical values. You go deal with that part. Find your derivative, and then tell me the x values where the derivative is 0 or is undefined. So my derivative is 12x cubed minus 12x squared. I'm going to factor out at 12x, actually a factor out of 12x squared. And get this. I think this is going to give me x equals 0 and x equals 1. And those are my two critical values. Now I'm going to go make a table of values. Within the table of values, I need to include my critical values, because those are two places where I could have an absolute max or an absolute min, and also the endpoints, because those are also places I could have an absolute max or an absolute min. So I'm going to fill in -1, 0, 1, and 3. By the way, when you do this, you'll be asked to justify your answer. Your table of values will be good enough justification, but you've got to make sure you're labeling the columns in the table of values, x and f of x. If you have a table with no headings, it won't count for credit for the justification part. Then, all we have to do is plug our x values into f of x, into our original function, so we can look at our y values there. I'm going to do 3 times -1 to the 4th minus 4 times -1 cubed. 3 times 0 to the 4th minus 4 times 0 cubed. 3 times 1 to the 4th minus 4 times 1 cubed. And 3 times 3 to the 4th minus 4 times 3 cubed. Take a moment and see what you can do with these. By the way, this would be a non-calculator thing. This entire unit is without a calculator. Otherwise, we could just graph our function and do second calc, find the max, which is not what we're going for. So yeah, for that bottom one, you may have to write out some calculations so you can figure things out. Take a moment and finish off your table. This gives me -1 to the 4th is 1 times 3 is 3. -1 to the 3rd is -1 times -4 gives me +4, so I'm going to get a 7 over there. This one's easy. 0 minus 0, that's 0. This one is 3 minus 4, that's -1. And this one, let's see, 3 to the 4th is 81. 81 times 3 is 243. Over here, 3 to the 3rd is 9. No, it's not. 3 to the 3rd is 27. I didn't say that. 3 to the 3rd is 27. 27 times 4 is 108. And then 243 minus 108, 135. To finish this off, I look at that table. Here's my highest y value, 135. Here's my lowest y value, -1. My absolute max is 135, and that occurs at x equals 3. Oops. And my absolute min is -1, and that occurs at x equals 1. The video is going to pause. If you need a moment to finish copying things down, please do that. Let's look at 2 more problems. Let's find the absolute extrema, the absolute max and min of f of x equals 2x minus 3x to the 2/3, which I'm going to do on the closed interval from -1 to 8. See if you can find your derivative, and then see if you can find your critical values and send those in. Let's see, this is 2 minus 2 over x to the 1/3, but that's not going to be super helpful for me. I got to get a common denominator here, so how about I do 2x to the 1/3 over x to the 1/3 minus 2 over x to the 1/3. So 2x to the 1/3 minus 2 over x to the 1/3. Now how about you go find those critical values? We'll set the numerator equal to 0. I'll set the denominator equal to 0. Numerator 2x to the 1/3 equals 2, x to the 1/3 equals 1. Cube both sides, x is going to equal 1. X to the 1/3 equals 0. Cube both sides, x is going to equal 0, and those are our 2 critical values. We now need to go make our table. I need to use -1, 0, 1, and 8, my 2 critical values and my 2 endpoints. Go do it. Go fill in your table and see if you can tell me what the absolute maximum is and where it occurs. Make sure you're kind of writing it the way we did in the last one, absolute max, so tell me the y value at x equals, tell me the x value, and the absolute min. Remember that we're going back to the original. It is a common mistake to plug into the derivative. Don't do that. Plug into the original. -2 minus 3 times, okay, -1 to the 2/3. Square -1, you get 1. Cube root of that is 1. So -2 minus 3 is -5. 0 minus 0, that's going to give me 0. 2 minus, okay, 1 to the 2/3. Square 1 is 1. Cube root of 1 is 1. 2 minus 3 is -1. Over here, 2 times 8 is 16. 8 to the 2/3. Cube root of 8 is 2. Squared is 4. Times 3 is 12. And there we go. Actually, looks like in this case they both occur at the endpoints. We're going to say that the absolute max is 4, and that occurs at x equals 8. And the absolute min, or the absolute minimum value, is -5, and that occurs at x equals -1. Last example. F of x equals x over x minus 2 on the closed interval 3 to 5. Take a moment, find your derivative, and find your critical values. I'm going to use quotient rule on this. F prime of x equals low x minus 2, d high is 1, minus high x times d low is 1, Draw the line square below over x minus 2 squared. X minus 2 minus x over x minus 2 squared. This is negative 2 over x minus 2 squared. Numerator never equals 0, but the denominator equals 0 at x equals 2. However, I don't care about this critical value. I only care about critical values that would be within this interval, and I don't have any of those. 2 is outside my interval. So, when I go to make my table, I'm not going to put any critical values in there. I'm only going to put the endpoints in there. I'm only going to deal with 3 and 5. Go finish off the problem. Looks to me like 3 is bigger than 5/3, so there's an absolute max of 3 at x equals 3, and there's an absolute min of 5/3 at x equals 5. And this is how we find absolute maximums and absolute minimums, the absolute highest y value and the absolute lowest y value. We use our candidates test. We find all of our candidates, so our critical values and our endpoints, and then I plug those candidates, those x values, into my original function and compare y values.